All right, so today we're going to be kind of using the patterns that we used, discovering about the slope of a line and moving all the points down. And we're going to be putting them together so that we can graph a little bit faster using the patterns that we already discovered. And I'm going to show you kind of what your high school teachers and even college, if you're going to go to college and even do a basic math class, they're going to be doing lines pretty much in this exact way. So this could be, dare I say, some of the most important notes in your toolbox. So here we go. All right, so I'm going to, let's see, I'm going to start with the equation, and it's going to be an equation that kind of looks like the one we did yesterday. I'm going to start with y equals. My equations pretty much always want to start with y equals when I'm talking about these lines. Eventually you might see equations that look a little bit different. They'll still have x and y in them, but they might not start with like y equals like this one. But this one starts with y equals, so your y coordinate wants to be, and it's going to be something times x. The last toolbox notes we did was 3/4, a positive 3/4. So I'm still going to do a fraction, but just to kind of throw in another example, I'm going to do a negative number, and I'm going to do negative 3/5 times x, or you can just do negative 3/5 x, but I don't know, I kind of like reminding myself that they're being multiplied. And then I'm not going to keep my line, this goes through the origin right now, and I kind of want to move it up or down a little, so let me move it, I'm going to move it up, because we moved it down the last time. I'm going to move it up 7. That sounds good. All right, so this is my equation. Now I'm going to use the patterns that we did with y equals 3/4 x, subtract 5, and kind of think about it more conceptually. So if I were to start with just this equation, it would go through the origin, because if you choose x to be 0, negative 3/5 times 0 would mean your y coordinate also wants to be 0. So it would start there, but because I have plus 7, that means my origin is going to move 1, 2, 3, 4, 5, 6, 7. All right, now the other thing is, this has a special name, this point. Yesterday, or in our last toolbox notes, we talked about how this was called, we called it where the origin moves. Because the origin started here, it can move up, it can move down, but it always stays right here. Now I want to tell you what the new vocabulary word you might see is for this, and it's called the y-intercept. And it's called the y-intercept because this axis that I'm moving along, even if I move my origin up or down, I'm staying on this line, and this line is called the y-axis. So that's called the y-intercept. So this is like a super important number to start with. I always start with this number because it for sure gives me a point on my line. It gives me a place to start, and it's right in the middle, so it's just great to start with. Now, part 2 is to find, well, we have 1 point. We need to find like all the other points. So I'm going to use now my lattice pattern that I know from my slope, right? This is my slope. I'm going to give them 2 other names in a second also, just to make things more confusing. But this is my slope. Positive 3/4 x was going up 3/4. Negative is going to be going down. So on my negative 3/5, my slope, this is going to be kind of thinking first, I'm going down 3 because it's negative, and then over 5. All right. So my slope is super helpful because now I can find the rest of the dots. All right. Now, starting from here, right, because I'm not going to start the origin. I know my first dot is kind of right here. I can start going down 1, 2, 3. Actually, let me zoom in so maybe it's a little bit easier. So from here, I'm going to start going down 3 and over 5. 1, 2, 3, 4, 5. Perfect. And then I have another point. And then I'm going to start going down 3, 1, 2, 3, and then over 5. 1, 2, 3, 4, 5. And then I think I can fit 1 point in backwards if I go right here. Beautiful. So now, to check myself, get a nice ruler going with a line through it. And I think, okay, are these all lining up? They are. Great. So I can get a line through that. All right, and because my line is going down, I'm going to put a little arrow right there. Okay, great. All right, so we have our slope. Ooh, my y-intercept, I forgot to write it up here. My y-intercept, when I write it, it's actually a point. So the point of this line that goes right here is the point x is 0, y is 7. So a lot of people just say, oh, the y-intercept is 7. And that's kind of true, but kind of not true, because really it's this point, 0, 7. All right, so do you see how both of these things, you're going to see them in your equation. All right, so now all we have to do is go fill out our table. And actually our table is really important because if you're not sure if you did this correctly, your table is actually going to help you check that. All right, so first I'm going to put my equation right here. So your equation is what turns your x, like whatever you choose for x, into your y coordinate. So it's like this kind of machine that moves this way. And our equation is this right here. So I want to take -3/5, multiply it by x, and then add 7 to whatever that is. And then I'll get my y coordinate. All right, so we're not going to check every single point, but we are going to check a couple of them. The point that goes in the middle of our table is going to be this point right here, our y-intercept. I love putting that in the middle because like it's in the middle of our graph. We kind of want it to be in the middle of our table. All right, so our y-intercept, the x-coordinate is 0. And I mean, we kind of already know what the y-coordinate's going to be, but we should just do some math, just in case. So I'm going to do -3/5, my slope, times, and actually I should use parentheses, times 0 plus 7. And let me see what I get. Well, anything times 0 is going to make this 0. And then 0 plus 7 makes 7, which is great. We wanted the point 0.07. Now we're going to check another point, which I'll check right here. So this point right here, right after 0.7, I'm going to put that next in my table. But I've got to figure out what the x and y coordinate of this point are. So let me just like do an arrow right here so that we know that this is the point I'm talking about in particular. So the x coordinate of this point is positive 1, 2, 3, 4, 5. Nice. Okay, the x coordinate is 5. And then the y coordinate is positive 1, 2, 3, 4. So 5, 4. So my equation should be able to turn this 5 into a 4 if I've done everything correctly. So let's check that. All right, so my x coordinate is 5. I'm going to take -3/5 times 5, add it to 7, and I'm really going to hope I get 4. And actually, I'll show you how to type this in on your calculator on your phone, because you might not know this. All right, so -3/5. Most phones, unless you have a fancy one, sorry, it's cracked by the way. Most phones don't have a like fraction button like your calculators do. So what I do, sorry, yeah, oh, it's really bad, is I do -3/5, which is technically -3 divided by 5. So do you see how that looks a little bit different for my equation? And then I need to multiply that by 5, right? Because that's my x value. And then I want to add 7. And do you see what I get? 4, which is exactly what I wanted. Do you remember how this point was positive 5, positive 4? So this is great. Now, I could like keep checking all my numbers, but what I can do now is actually notice a pattern that's kind of going on here. So right here from 0 to 5, I kind of want to think to myself, what am I adding here? Well, what do you add to 0 to make 5? It's 5. So if we had a guess at what our next x value was going to be, well, what's 5 plus 5? It is 10. That's right. And -3/5 times 10 plus 7, it's going to give you some number, but we're not going to look at our graph for it. We're going to use this pattern that we have right here. Okay, going from 7 to 4. Think about how you go from a positive 7 to a positive 4. Are you adding something or are you subtracting something? Drum roll. Yes, you are subtracting something. You're subtracting a 3. And that's what you're going to keep doing, because when you have linear equations, they're always going to be adding the same amount every time or subtracting. by the same amount if you're taking these steps. So linear equations are always going to have these nice patterns. In high school, you might not have such nice patterns, but there'll still be patterns, they just won't be the exact same every time. They'll be more complicated. All right, 4 take away 3 is 1. And then I can go backwards a little bit. So what would I have to subtract 3 from to make a 7? Let's see, I think that's, if I go backwards, it'll be 10. And then if I do that again, what subtract 3 makes 10? That's 13. All right, and then going backwards here, I don't know, my x's are always kind of easy, right? Because 0, 5, 10, 0, negative 5, negative 10. All right. Now, I don't know if you've noticed, but our slope is seen in these side pieces. Remember how everything was going down 3 and over 5 on our graph and on our slope right here? Well, that's exactly what's happening here. Y going down by 3 is making our graph go down 3. X going up by 5 means your graph is going over 5. So every time you go over 5 on your x's, you're going down 3 on your y's. It's not really a coincidence. All right, so finishing this up, just to make it look complete and nice, you don't have to type these in on your calculator, but I hope by now you feel really great about them actually being the correct numbers. So everything should work together, right? You see like so many patterns that are similar all over this. All right, now I want you to know one last thing. Slope has another name in your equation. We like to give this a variable name. And in high school, the variable that they always give slope, you're never going to guess it because it's really stupid. It's m. M for slope. Does it make sense? Not really. And then your y-intercept, or whatever you're adding or subtracting, they call it b, which is also really interesting. I didn't really choose this, but I'm going to go ahead and fold this up because putting all this together, your linear equations are always going to look like y is equal to m, your slope, times x, and then plus a b. So everything's going to move up or down. So this is called slope intercept form. And this is probably the most common way you'll see equations in math class, probably, like I said, from high school through college. And the slope is this part. It can be a fraction, it can be a whole number. It's just, we call it m for some number. Intercept is right here. It's technically your y-intercept, right? Because it's what moves your point up or down right here. But, I mean, it doesn't look pretty, I'll be honest, but we'll get a lot of practice in on this and kind of exploring more about it so we can get used to an equation with 4 different variables. That's a little crazy, but it's not too bad once you practice it enough times. You just got to remember slope, intercept, form, because that's what these two kind of mystery numbers are. All right, let me know if you have any questions, and let me know if you need one of these papers. I mean, if you got to the end of the video and you didn't have one of these, yikes, man. Let me know, though. All right, bye-bye.